Hello and welcome. This is a lesson on weather prediction. Get ready to learn. We're going to learn about what it takes to put together one of these weather maps. Did you know? Weather is difficult to predict. Scientists who study the weather are called meteorologists. They do not study meteors, they study the weather. And a storm is any kind of severe weather like rain, snow, or a thunderstorm. Why is this important? Well, the weather is always changing. Be nice to know what it's going to be. Predictions, weather predictions, help us make plans. And pilots are pretty much the most important people to know the forecast to fly a plane. You do not want to fly into storms if you can avoid it. And if there are storms, you can prepare for them. So, what's important to know about weather prediction? Well, weather instruments collect information. Here is a weather station. This is a remote weather station. Looks like it's in a very cold place. Some of these are on mountaintops. Some of these are on ice floes. Some of these are floating in the water, in the oceans. Some of the instruments that are on a typical weather station would be a thermometer to measure the temperature, an anemometer to measure the wind speed, a rain gauge to measure, rain, a barometer to measure air pressure, a barometric meter, a thermometer. That's how the words are crafted. A hygrometer, hygro meaning water, measures the amount of humidity that's in the air. Windvane, to measure the wind direction. And we'll talk about all these too. A snow gauge to measure the amount of snow, and some even include radar to measure wind and cloud formation, where the wind's going, where it's coming from, and clouds in different layers of the atmosphere or different altitudes. So we're going to talk all about these. First one is a barometer. It measures the air pressure. This is kind of a fancy one. This is not a direct read. This just gives you an indication of the air pressure, and this is how it works. This is a glass ball with a tube that is open to the air. Now, the higher the air pressure, the more this column here is pushed down, compressing the air that's in here. So if it's high up in the tube, it's low air pressure pushing down. If it's way down here, we've got a lot of pressure pushing, so we're in a high pressure system. So they're either direct reading or recording types. So you can see this one. Here's another version. There's another kind of recording of air pressure inside here, and it's linked to this dial, where you can directly read 76, 77 millimeters of mercury, so it's 76.6, I would say. millimeters of mercury. That's a column of its measurement of the barometric or barometer pressure. So you can either look at this and go, oh, it's 76.6 and record it somewhere. Or you can put a piece of paper on a spinning drum and attach a pen to it through some links to another type of barometer. And the higher the pressure, the more this gets squished together like an accordion. And the linkage will record on this rotating drum. So once a week, once a month, you change the paper on the drum and you can record the barometric pressure. So we have visual, we have a number, and we have recording barometers. Thermometers. They measure air temperature. Oh, if you put them in water, they're going to measure water temperature. But we're talking about measuring the weather. We want to measure the air temperature almost always. They come in different versions. Here's an alcohol one. In this tube, it's sealed at the top. And there's a vacuum in here. There is a bulb at the bottom here. Let me make it bigger. Down here, there is a reservoir. And as this heats up, it pushes. This is colored alcohol. It's red colored, so you can read it easy. It pushes it up because it expands. And the hotter it is, the more it expands. And it goes up, and there's a meter here that you can use to measure the temperature directly. Here's a second version that is very similar, except down here, see the silver? That's mercury, not the planet, the metal. Mercury is a liquid at room temperatures. So within a certain temperature range, this is going to work very well because it expands a lot. So the further the greater the rate of expansion, the more accurate your reading could be. And they read the same way. Now, a totally different way is to bounce a laser beam off what you're measuring. And that's what this one does. And it will give you a temperature reading directly, either in Celsius or Fahrenheit, depending on how you have it set. You have an electronic one. Up at the tip here, two metals meet, and their resistance varies with the temperature. And it comes down the wire and is manipulated inside here, and it gives you a direct reading of the tip of this probe. And then you have something called a bimetal. It's bimetallic. In other words, two pieces of metal are sandwiched together, but when they heat up, they're of different metals, so they heat at different rates and bend because they're held together. So that deflection or bending is tied right to, let's go back. It's tied right to a spring, and this will go down when the metals straighten out, and it'll go up when they deflect. So, alcohol, mercury, laser, electronic, and bimetallic. all different thermometers, hopefully reading the same temperatures. Now, this is an anemometer. It measures the wind speed. You can see these cups. This side is different than that side. One is a cup and one is rounded. So when they're in the wind, the cup side is going to catch the wind and the other side is going to push against it. So it spins in the wind, and they're sized to reflect the wind speed. So the faster that spins around, that means there is a higher wind speed. Here's a different version of the same idea. There's a propeller in here, and you turn it on, you put it in the breeze, you aim it so that the breeze hits, and you measure directly. It converts it right to either miles per hour or kilometers per hour. Two different kinds, but still it measures the wind speed. Something spins around in the wind. This looks like a cup or a bucket. A rain gauge. It gauges or measures the amount of rain. Rain falls in, fills it up. Not too hard. It measures liquid precipitation. It's not going to measure, of course, it's going to be off if it measures snow or hail or sleet. They must be emptied, but there are some models that are self-resetting. After a certain amount of time, it'll tip over, dump it out, and reset. A hygrometer measures the amount of humidity or water vapor in the air. You can have a direct read like this one. This is 44%. Here's percent. Or you can have an electronic one. This one's measuring 36% relative humidity. So you have hygrometers measuring the amount of water vapor in the air. A Windvane. It shows the wind direction. Now the arrow always points to the direction the wind comes from. That's how winds are named. This one, let's see, the arrow's pointing west. So this is a westerly wind. So you got north, south, east, west, and of course in between. The direction the wind comes from is what it's named after. Guess what we're measuring here? Snow. It's better known as a ruler. All you got to do is stick it in a flat level surface away from everything so that it's not covered or influenced by a house, a tree. Here's another version. A little different. It measures what falls inside. Excuse me. Okay, here is a weather station. As you can see, it's in a pretty remote area. On this weather station, we have a thermometer to measure temperature, an anemometer to measure wind speed, a rain gauge to measure the rain, a barometer measures air pressure, a hygrometer measures the humidity in the air, a windvane measures wind direction, and a snow gauge measures the snow. This one is powered by solar cells. Not a lot of places to plug it in up there. But it also has a battery backup for during the night, because weather doesn't stop just because the sun goes down. In fact, it changes when the sun goes down. Radar. We have different kinds of radar. Different kinds of frequencies are used for clouds and wind speed. And maybe we've seen pictures like this on the news. Here's the radar station itself in the center, and it sweeps around. An antenna inside here, the radar dish, sweeps around, and the information's fed to a computer. Then it sweeps around again and fed to the computer again, and the computer glues these all together and makes a movie of what the clouds are doing. You can see them moving. Now, remote sensing, satellite sensing. Satellites can see in many wavelengths from far above the Earth, so they can tell different things based on what they're receiving information on. Different wavelengths are different temperatures, and different temperatures can be made into different maps using computers. Computers can process the information quickly. There is so much information that without computers, it would take so long to collect it that it wouldn't be good anymore. It would be hours and days in the future. So computers allow us to take the information and put it into a model or a graph or a picture and be able to use it. The weather stations feed information directly into a central computer. And remember, we're taking a reading here, and we're taking a reading here, and we're taking a reading here, and we're taking a reading here. But the Earth's a big place. So to gather all that information together and make it into something useful, we need remote sensing, give us a bigger picture, and computers. What's important to know about weather prediction? Well, the most important things is maps of pressures and temperatures. Knowing the pressures of the air pressure and the temperature allows us to visualize information, to be able to see patterns. These are generated by computers. And the barometric pressure is connected on an isobar map. Here's an isobar map. These lines here, let me make that bigger. These lines here, everywhere on that line is the same barometric pressure. Everywhere on this line is the same barometric pressure. And that allows us to see how the air masses are constructed. There's also other information on this weather map that we can use. But the map of pressures and temperatures is the most important here. We have wind speed also, we have temperatures, we have jet stream. There's a bunch of other information we can get based on what we're asking for. Here's a temperature map. You can see the temperatures here where the deserts are. The desert here, desert in the Midwest. So we have, and then we have cold at the poles. So maps of pressures and temperatures are generated by computers using remote sensing and direct sensing of weather stations. Now, having all this information, we can build models. We can build predictions. This is the U.S. Winter Outlook. Is based on previous weather and predictions of future weather, December, January, and February. It looks like it's going to be warmer in the south and cooler along the coast here. Cooler than what? Cooler than normal. Now, computers make these predictions because there's just too many numbers to crunch for humans. And prediction accuracy falls off as prediction days are further out. In other words, you could probably tell this afternoon's weather based on this morning. Tomorrow gets a little more iffy. Next week, even more. Next month, even more. So the further you go from right now, the less accurate you are in predicting. That just makes sense. Trying to predict the future. So why is this important? Weather is always changing. Predictions help us to make plans. And pilots are probably the most interested in knowing the forecast because they have to fly through any kind of weather. And there's your lesson on weather prediction.